Okay, Assalamu alaikum. My name is Muhammad Abdel. I'm from Group 1, and my topic about 3D bioprinting in dental applications. Here today, I have Muhammad Al with me. He's a mechatronics engineering, semester 5. Yeah,
My pleasure.
nice to meet you. Nice to have you here.
Mm, Thank you.
Okay, so I believe since you are mechatronic, you have a background in 3D printing, right?
Yes.
Yes.
3D printing SolidWorks on this point.
Mm-mm. So have you ever heard of 3D bioprinting?
Bioprinting? No, to be honest.
No, I didn't hear. Okay, nice. That's what we are going to discuss today. So let me introduce you. So 3D printing is an advanced manufacturing process that deposits living cells and biological materials known as bioink, layer by layer, same as the regular 3D printing, to construct 3D dimensional tissue structure. Okay, we have a conventional printing use instead of plastic or metal. We use a gel loaded with living cell, protein, and supportive scaffold materials. In dentistry, 3D fabrication, patient-specific replacement for teeth, gum tissue, jawbone, and internal dental structure, all custom built from a digital scan of the patient mouth. Okay, so this is the term of bioprinting. Let me walk you through the process. We have five main steps here. First, scan. Second, design. 3D load bio ink. And then printing. After that, mature and implant. So I'll go one by one and explain each step. So first one, we have the scan. We use the 3D digital scanner to scan the surface of the mouth. Like the surface inside the mouth is kind of weird. It's not like straight surfaces, stuff like this. You cannot measure with like caliber or something like this. You need a digital 3D digital scan. After you scan the surface, you go for the next step, which is the design using software design. Since you are in mechatronics, I think you're familiar with SolidWorks, right?
Yeah. I use it a lot. It's a
So
piece of cake for me.
yeah, it's instead of SolidWorks, we have like different software here. Uh, many different type. Let's use surface modeling, so we can generate like this weird looking surfaces to fit the mouth of the patient. Okay, so
Mm.
after that, we load the printer with the bio ink, which is gel-like mixed of living cells, protein, and supportive biomaterial. After that, we start printing, which is fourth step. The printing builds the structure layer by layer, following the digital design with the high precision. The same design from the second step, it will turn to reality by the printer. Same as the regular 3D printing, but instead of having plastic or metal, as I discussed earlier, we use bioink, which is
Okay.
which is like a living material, let's say. Yeah.
Okay.
And lastly, we have mature and implants. The printed tissue mature in a controlled environment, since this is not just a plastic or metal, this is living cells. So we cannot just process it by heat or wash or stuff like this. We need to let it grow in a mature and controlled environment before being placed inside the patient mouth, where it integrates over time with the other tissue and grab its place.
Oh, yeah, that's
Yes.
right, actually.
So this is what the process. Let me tell you about the key dental application over here. We have like four application here and many other more, but this is related to the dental specifically. So dental restoration. So custom crown, veneer, bridge, and denture printed to assist dimension of a patient mouth, often completed in a single clinical visit. So it's very quick. It's happening in like one visit. You go to the hospital, they print it quickly. Like if your tooth, as you see in this picture, is damaged, they can replace it can print a crown to fit in the same tooth, let's say. Okay,
Okay.
and we have bone regeneration. Bioprinted bone scaffold help rebuild the jaw after tooth loss or injury, providing a solid foundation for dental implant. So if your jaw itself is damaged, your teeth is lost, stuff like this, you need the bone to help something to help the bone regenerate it, rebuild itself. We use also 3D printing to give this support for growing.
Okay.
Other thing, we have the gum tissue repair. The tissue is the one that holds the teeth in its place. Brain gum tissue can treat gum diseases and reseeding gum without harvesting donor tissue. Yeah, so you don't need to like remove the gum itself from other places to heal stuff. You can just print a new tissue and place it on the mouth. And also we have the drug delivery. Tiny printed implants can be placed in the mouth, releases antibiotic in controlled localized manner. So this is the main application here. Okay, as everything will have an advantage and disadvantage. So the advantage here we have like a perfect custom for every patient. As I say, you scan and then design. So this will be specific to each patient, not like having one piece trying to fit it inside each patient mouth. We'll have a custom piece. This, and then it's just faster treatment. It's often in one single visit. You don't need to visit the hospital today and wait like weeks or stuff like this. You just come, they print implant, and then you go. And it also reduce pain and recovery time, as we discussed in the gum tissue repair. You don't need to remove from other places. Just quickly print and plant. And also we have living tissue integration, not just synthetic plastic. Don't use plastic, metal, stuff like this. Use actually living tissue to put inside your body. So that's that's like more favorite to the body, and reduce relying on the tissue donor. You don't wait for another donor or take tissue from other place of the body. Just print a new one. Yeah. So this was the advantage of it. And then we have the disadvantage, or we can say the current challenge, stuff we're still working on. Like most applications still in experiment or clinical trial phase. It's like a new technology, so gotta have more testing and high cost, as same as any new technology having. Make it high, be sometimes be high cost. That means not accessible to all people. Not all people can print. Yeah, this is the problem with the high cost. And then we have long-term duration data still being gathered. As I said, we need more testing to collect more data to see how to improve it. And also we have regulatory regulatory approval pending in most countries. As I said, it's new technology. You need to wait for policy and ethical analyzation for this technology to know how to use it and how not to use it. So after this, we have where the field is now today. Okay, now it's widely available. 3D printed crown, denture, and surgical guide are standard in many modern dental clinics worldwide. This type of application is now like more accessible. In the near future, bioprinting bone scaffold and gum tissue are in clinical trials and expected to reach patients soon. Like I said, it's in ex- uh, experiment or clinical trial. It's need more testing and more data collection. Further ahead, fully bioprinted living tooth growing from the patient's own cells remain the long-term goal of the field. This is what the researcher aim to do, to build the full teeth outside the body, to implement in the body from living cells instead of like plastic or metal or stuff like this. I have living tooth outside of the body and printed inside the body. So I believe this is all what I have today for the 3D printing. What's your
Wow.
feedback about what you hear today?
Wow, that's actually very informative information. Like I never knew that such materials as such approaches are exist. Wow,
Mm,
that is like really amazing. Thank you
yeah,
for illustrating this information for me.
you're welcome. It's more like the 3D printing, but you never thought it
Mm.
could be used in living
Yeah,
tissue. Yeah,
yeah, yeah.
yeah,
Actually, same as like sci-fi movies, you know.
yeah. I can
Oh,
understand. Yeah,
yeah,
that my same reaction actually. Yeah, but when I
mm,
first heard about it. Okay, okay, Wathiq, thank
yeah.
you for being with me today. I really appreciate it, and
You're most welcome.
thank you for listening today. Okay, and that's all I think for me.
Have a good night.
Have a good night.